Welcome to podcast 2. All right, so we're going to look at combination of transformations. We're going to identify different transformations in this graph, because it's only one graph. So we're going to identify the amplitude, the period, the vertical shift, and the phase shift. And while I'm going over these, see if you can come up with the answer yourself. Just moving this one up a little bit. All right, so let's look at the first one. What is the amplitude? All right, so do you think you know what the amplitude is? Amplitude. Amplitude is always the coefficient in front of sine or cosine. So our amplitude is equal to negative, just take the absolute value of it. All right, so that's our amplitude. All right, see if you can identify the period. All right, so the period equals, well, my b value here is right there in front of x. There it is. My b is equal to 3. So my period is going to be 2 pi divided by 3. That will be the period for this graph. Right? So the period for f of x equals 2 cosine 3x minus 6 plus 5. It's going to have a period of 2 pi thirds. That's how long it'll take for it to go through the cycle of points. All right, let's look at the next one. What is the vertical shift of f of x equals 3x minus 6 plus 5? Do you know what the vertical shift is for this graph? All right, your vertical shift is always what's added to the whole function. So in this case, the vertical shift is going to be up 5. And our midline will be y equals 5. All right, last, the phase shift. Before we can identify the phase shift, we do have to factor out b. I didn't do it I could have done it up earlier, but I decided to wait until we got to the phase shift. So I'm going to factor out b, which is 3. And if I factor out the 3 and divide both of those by 3, I'm going to have x minus 2. So that means our phase shift is right 2. Sorry, I started to glance at that plus 5. Right 2 is our phase shift. And there you go. There's all the things. So this graph has an amplitude of 2, which means instead of oscillating between negative 1 and 1, it's going to oscillate between negative 2 and 2. It has a period of 2 pi thirds, which means we're going to see all of those points. In this case, it's cosine. So it'll go through the 2 maximums, the 2 x-intercepts, and the minimum. And it'll do that in 2 pi thirds. And then it will keep doing it every 2 pi thirds. It's going to be vertically shifted up 5. The midline will be y equals 5. And it's going to be shifted to the right 2 units. All right? So that's all the things that are going on with this graph. And we'll learn how to graph all of those things. All right, so recall, to combine transformations, we have to follow order of operations. All right, so if we look here, y equals a, f, b, x plus c plus d. That's lots of letters. F just means the function. That's sine or cosine. So we want to make sure that we take care of the period changes and the amplitude changes first before we take care of our phase shifts and our vertical shifts. All right, so we're going to stretch before we do a horizontal shift, and we're going to vertically stretch by a factor, whatever our amplitude is, before we translate. Okay? All right, so if we have, here's all the parts of the equation. I think this is in your notes. If not, you might want to write this down so you can see it all together. Our amplitude is the coefficient in front of sine or cosine. If it's negative, the graph also reflects over the x-axis. Our phase shift, if our b is not factored out, this is only if b is not factored out of the parentheses, it's going to be that c value divided by b. Or just factor out b first. Usually that's easier. And if it's not in the parentheses, you don't have to worry about it. To find the period for the graph, you're just going to take 2 pi and divide by b, and whatever d is, that's your vertical shift. Whatever's added or subtracted to the whole function is a vertical shift. Okay, so let's take a look at all of these things. We'll take a look at them and identifying them in some equations. We'll also graph some of those. All right, so here we're going to identify these in some equations. We want to identify the amplitude, the period, the phase shift, and the vertical slide. Okay, all of the things. The very first thing I'm going to do before I do anything else is I'm going to factor out b, so I don't forget. And if you want an example of identifying everything and simplifying it, this is a good example. So we have y equals, for your notes, y equals -2 sine. I'm going to factor out the 4. If I divide 4x by 4, I'm going to have x. If I divide pi by 4, I'm going to have pi fourths. We can always check ourselves by multiplying 4 times pi fourths. Maybe you don't think you got it right. So if I multiply it, I'd have 4 pi over 4, which is just pi. Right? So we got that correct. All right? So this is our equation here with the b already factored out. Okay? So now let's identify all of our important parts. All right? So let's identify our amplitude. Now our amplitude comes right in front of our function, but it doesn't include the negative. It's the absolute value. So it's going to be the absolute value of -2, or just 2. This particular graph is also reflected across the x-axis. The period of the graph, we just take 2 pi and divide it by b. Right there is b. Right, so 2 pi divided by 4 is going to give us pi halves. So it goes through the cycle every pi halves. The horizontal shift, or phase shift, I'll put phase or horizontal. It's usually called a phase shift. The shift is horizontal. All right, once we factor out b, we can see what it is. It's this value here. So our phase shift is pi fourths to the left, because it's positive. And it's positive in the parentheses. All right. The other way we can find it, right, is to take x plus pi fourths and set it equal to 0. And we'd have x equals -pi fourths. If we're setting it equal to 0, this negative means left. But if it's in the parentheses still, that positive means left. And then we have a vertical shift. And this value right here is the vertical shift. The vertical shift is down 5. And that's it. We've identified all of the different ways that this sine graph has been changed. And the amplitude, the period, it's been shifted both horizontally and vertically. Okay? If you have any questions in class, let me know tomorrow. All right? But let's do a few more. All right, so we're going to identify all of these things in our graph. And it says classwork, but I think it was classwork at one time. And I don't think it's I don't think it's in your classwork that I gave you. I'm going to actually skip this page, and let's do this in class tomorrow. So this will be my check to see if you watched my podcast. We'll do this one in class tomorrow. We'll do that together. All right, so let's look at the parts of a trig graph, sine and cosine. Our important things that we're going to be graphing are the amplitude, the period. We're going to graph one cycle of our graph, and then is there a vertical shift or is there a horizontal shift? And we'll be graphing both sine and cosine. All right, so because sine and cosine are periodic functions, they repeat their values in a regular pattern, okay, so that they are periodic functions. A periodic function is a function f such that f of x equals f of x plus np. The np just means that for every real number in the domain, there's every integer n and some positive number p. So p is the value of the period of the function. All that means is it's going to repeat that every period, whatever the period of the function is. So if it's just y equals sine x or y equals cosine x, it's going to repeat it every 2 pi. Every 2 pi, I'm going to have the exact same graph. So whatever all that is saying, the n and the p, is that whatever the period for your graph is, it's going to do the same thing every single period. You're going to have the exact same graph forever and ever and ever. Okay? So sometimes we write that it's repeating. It's going to repeat every so often, and sometimes we just graph one period of the function. We're just going to focus on graphing one period of the function. Okay? All right, so you begin by adjusting the reference period. So we're going to have a base graph. It's our 5 key points. We start with the standard key points. The first thing we're going to adjust are the x values. We're going to determine where so it says our new reference period begins and ends. What that's referring to is how long does it take us to go through one cycle of the graph. If the period of the graph is not 2 pi, then we're going to have to change our x values for the graph so they correspond with when the function would go through its 5 key points. All right, so if the period changes, we're going to change x. And we do that simply by figuring out what 1/4 of the period is and by counting up by whatever that value is. If there's an amplitude change, we're going to change y. That'll be our base graph. So your base graph is going to be your 5 key points with x adjusted if there's a period change, and y adjusted if there's an amplitude change. And then you can translate your base graph horizontally and vertically if applicable. And I will show you one other way. If you want to do just one graph, I will show you how to change those points for horizontal and vertical translation. Or you can just count. I generally just count. Sometimes I write down the values just to check myself, make sure I counted right, but I generally count. So now we're going to get to some graphing. And I think some of these are in your notes. I erased them for me, but I left them for you. And I don't remember which ones, but I think this might be one. So we want to graph y equals 3 sine of x. Right? So notice that the only change we have here is that we have an amplitude change. That means our x values are going to stay exactly the same. So when we do our table, we're going to have x, and we're going to have the old y's and the new y's. All right, so I'll put the old y's, I guess, I'll put them in green. The word's written in red, but I'll put it in green. So y equals sine x. So for sine x, it's going to be 0 at 0 radians. It's going to be 1 at pi halves radians. It's 0 because it's going to be on the x-axis, and sine is the y values. It's the opposite, right? So it's going to be 0 at pi. It's going to be -1 at 3 pi halves. It's going to be 0 again at 2 pi. Okay? And if you didn't have a chance to copy down a little unit circle with those values, you can write that down. That might help you. All right, so 3 sine x. I'm going to keep all my x values exactly the same, but we're going to change our y values. So in other words, we're going to multiply all our y values by 3. So I'm going to multiply this one by 3, and 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 this one by 3. All right, so that's going to give me 0, 3, 0, -3, 0. The amplitude of y equals sine x was just 1, but the amplitude of y equals 3 sine x is going to be 3. So the only change in our graph is the range, which changed from -1 to 1 to 3 to 3, -3 to 3. Okay? All right, so I'm going to draw y equals sine x. You do not need to graph the base function. You don't let me say that again. You don't need to graph y equals sine x or y equals cosine x on any of these. You just would need to graph y equals 3 sine x. I'm just going to draw the graph just so you can see what it looks like in comparison to y equals sine x. And so, whoops. Not even just. So it would have been a nice graph if I hadn't missed that point. Kind of bothering me. Let me try it one more time. Good. I guess that's as good as I'm going to get on the smartboard. So that's what y equals sine x looks like. Here, so I'm going to write that in. Y equals sine x. And it would repeat. It would do the same thing over here, right? So it would just, here, I'll kind of do it as a dotted graph. So it would look the same over here. And it would, I don't have any more right to go to. And it would look the same going to the right as well. The graph, though, that we wanted to graph was y equals 3 sine of x. My cord is stuck. And so we'd go through 0, 0, pi halves 3, pi 0, 3 pi halves negative 3, 2 pi 0. So this would be y equals 3 sine of x. If this were a homework assignment, I asked you to graph y equals 3 sine of x, the only thing you need to do is you need to give me the table of values, and it should look just like that. Actually, I tend to write them vertically, the numbers vertically. This table just went horizontally. And the blue graph, this one right here. And then I might ask for domain. The domain is easy. It's all real numbers for both sine and cosine. They both continue that pattern all along the x-axis. The range is going to be negative 3 to 3 with brackets because it does go through those values. And that's all you would need to do is the table of values, domain and range, and the blue graph there. That's everything. That's not so bad, is it? Okay. I'm actually going to erase this and do it with you. Some things I left up here because I thought it would save time, but I think I want to write it down so I can go over things. So here's a set of steps that we're going to follow. All right? So for graphing sine and cosine, we're going to list our key points: the x-intercept, the max, the min. You're going to identify your period and adjust x if there is a period change. You're going to have a new x. You'll identify your amplitude, adjust y if there's an amplitude change, and then we'll graph our base graph. Use the new x and the new y if applicable. Okay? Maybe you don't have a new x, maybe there's no period change. Maybe you don't have a new y, maybe there's no amplitude change. This one did not have a period change, this one just has an amplitude change. All right, so this is another one with just an amplitude change. So this is what I would want you to graph if this were your homework assignment, to graph y equals 1/2 sine x. All right, the first thing you would do is we're going to write in our table. Actually, I'll do the table first. This table is only going to need 3 columns because I don't have an amplitude change. All right, so I'm going to label this one old x. And I'm going to label this one new x. This one's going to be old y. And I'm going to put the 4th one in here just so you can see. Sometimes you'll have new y. Here we don't have a new y. And the reason we don't have a new y, I wish my microphone is just, well, only stretched so far. So I have to kind of to talk into the microphone and stretch my hand. There's no amplitude change. So I don't have a new y. So I'm just going to have the good old y's I had before. All right, so the important things for sine and cosine happen at 0, pi halves, pi, 3 pi halves, and 2 pi. Those values are signed as 0 at 0. It's 1 at pi halves, it's 0 at pi, it's -1 at 3 pi halves, and it's 0 at 2 pi. And it's always that, always and forever. We do have, oh, I'm sorry, I crossed off the wrong thing. We have an amplitude, we have a new y, I'm sorry. I said it earlier, and then in my head I didn't look up and see. We do have a new y, what we don't have is a new x. All right, sorry, no new x. My x is in the wrong spot. Oh, it doesn't want to move over. I will erase it. Sorry, that's what happens when I have to stretch and I can't move my head up to see the top of the graph, which I really can't do. So there's no new x, sorry, there is a new y. There's no new x because there's no period change. There's no, b is 1. I put the wrong thing in there. If I wasn't at 21 minutes, I'd redo the tape. But there's no period change because b is 1. There is a new amplitude change. We're just going to take our old y's and multiply by 1/2. So 0 times 1/2 will still be 1/2. 1 times 1/2 is 1/2. 0 times 1/2, you know. And -1 times 1/2 is -1/2. And 0 times 1/2 is 0. You don't have to write down 0 times 1/2. I'm fine. Oops. I think I even said 0. I'm fine if you just write down 0 1/2, 0 -1/2, 0. Right, that's fine. All right, so now what we have to do is graph. These are our x values, and these are our y values right there. All right, so we have the point 0, 0. We have the point pi halves 1/2. So it's going to go right there. We have the point pi 0. We have the point 3 pi halves -1/2. And we have the point 2 pi 0. And there's our graph. And our domain is all real numbers. And the range is -1/2 to 1/2. And that's it. We're all done. All right? So we're always going to have those 4 columns. Sometimes there's not a new x because we didn't do any period changes. And sometimes there's not a new y because we didn't have any amplitude changes. Oh, I feel so bad. I wrote the wrong thing in the column. I meant to write no period change, not no amplitude change. That's all we got here is an amplitude change. All right, so if b is greater than 0, the graph of y equals sine bx will resemble that of y equals sine x, but we'll go through the cycle. The graph will go through the cycle either slower if the period is more than 2 pi, or faster if it's less than 2 pi. Same thing for cosine. The graph of y equals cosine bx will resemble that of y equals cosine x, but the period's going to change. It's going to either be stretched out, more stretched out vertically or horizontally, or it's going to be shrunk horizontally, one or the other. I don't know if I should save the next one for... I'm going to save this one for class because I'm at 23 minutes, plus I did a 5-minute one for first period. Let's have a closing. I'm going to put the closing in right here. And we will be continuing graphing. And I may have a podcast for tomorrow, but I don't want to make too long a podcast each day. All right, so this is the closing for Wednesday. Identify the amplitude, period, phase shift, remember that's the horizontal, and vertical shift for the equation. Okay. So I have y equals 3 cosine Let's do six x plus 2 minus 4. There we go. So you're going to tell me what's the amplitude, what's the period, what's the phase shift, and what's the vertical shift. And I'll give you a hint. Don't forget to factor out B. That's my hint. Okay? All right, so I'm going to end this podcast, and then tomorrow in class, we're going to do those problems together that I passed, and we're going to graph now with phase shift, period changes, and with phase shifts and vertical shifts. All right, so bye for now.